Hi all, welcome to Tech Forum. In this video, let us see how to use Oak Lucene indexing to improve the performance of the JCR queries in AEM. For queries to perform well, Oak supports indexing of the content that is stored in the repository. When a JCR queries gets executed, usually it searches the index first. If there is no index, the query executes for the entire content. It will become a full traversal. This is time consuming and an overhead for the AEM. So it will impact the AEM overall performance. A query can be executed without an index, but for large data sets, it will execute very slowly, or even the query can be aborted. So because it should be doing a full traversal of the content repository. There are three types of indexing mode available. The mode defines how the comparison is performed and when the index content gets updated. So first one is synchronous indexing. So in this case, the index content gets updated as part of the commit itself. Whenever you do some content commit, the same time as part of the same thread, the index content also gets updated. So what is the use of this synchronous indexing is whenever you want to maintain the content uniqueness. So means like the index will reflect always the latest content. Those scenarios you can use the synchronous indexing. Obviously it will have some the index, the content, the performance impact. Whenever required, the synchronous behavior, we can use this. Changes to both the main content as well as the index content are done automatically in a single commit. The next one is the asynchronous indexing. This means the indexing is performed asynchronously. Also, this is called async indexing. It's performed through a periodic scheduled jobs. As part of the setup, Oak schedules certain periodic jobs which perform difference of the repository content and update the index content based on that. So whatever the new content added into the repository, those will be get included into the index through this scheduled job. So this will the indexing will happen asynchronously. Obviously, the index will not reflect the latest content. So when you don't want to maintain the uniqueness, then you can use for the asynchronous index. This will provide better performance again. Yeah, the next one is near real-time indexing. This method indicates that index is a near real-time indexing. So this will be between the synchronous and asynchronous indexing. Indexing uses commit editors. Some of the editors are of type index editor, which are responsible for updating index content based on change in main content. Whenever the main content is changed, the index should be updated. So those perform through the editors, index editors. Currently Oak has the following inbuilt editors. One is property index editor, then reference editor, then Lucene index editor, then Solar index editor. So obviously we can have our custom index editor also. There are three main types of indexes available in AEM. One is Lucene. Obviously it's a asynchronous. You can do full text or property based indexing here. This is the recommended approach. Then property index, that's a synchronous. Whenever, as we discussed, whenever you need a synchronous result, the result uniqueness, then you can go for this property. Then another one is Solar. This is again a asynchronous indexing. This can be also used for full text and property based indexing. Now let's see how to configure Lucene index in AEM. Oak supports Lucene based indexes to support both property constraint and full text constraint, or whatever we explain, whatever we see now. Depending on the configuration, Lucene index can be used to evaluate property constraint, full text constraint, path restriction and sorting. So all those things we can do with that. So if multiple indexes are available for a query, each available indexer estimate the cost of the executing the query is more like a SQL query, like a cost estimation. Then Oak then chooses the indexer with a lowest estimated cost. So now let's say a scenario. I have a list of data nodes like around 12k in my repository. Let me show that. Yeah. So if you see under the sample data folder, I have around 12k of nodes. So each node having only ID and name. ID is like all the IDs are starting with all 12,000 records IDs are starting with first four ones. Then it is an incremental number. So now I need to execute a query to find the nodes. Those are matching with the specific criteria. My scenario, I want to find out all the nodes starting with four ones. ID with the four ones. Now I'm going to use the SQL2. Even we can use SQL or XPath based queries, but I'm here using SQL2. Now let me like execute the query. Let's see. I'll go to tools, query. Let me take the query. Yeah, so this is the query. So if you see here, this is the this node, this individual nodes are type nt unstructured. So I'm select star from nt unstructured, where JCR path is like content slash sample data, then like and id like the starting with the four ones. Now let me execute this. Yeah, so it looks to be some issue in the query. Yeah, sorry, I did not select SQL2 here. Okay. Yeah, this exception says the query read or traverse more than 1 lakh nodes. To avoid affecting other tasks, processing was stopped. So like because there is too many traversing, as I told already, like there is no indexing, means it will do a full traversal. But it's after like reaching that specified count, the processing is stopped. So otherwise it will impact the overall performance of the system. So the same exception, if you go to the error log, you will be seeing the same exception. Let me show the, you should be seeing a warning. Yeah, see here now, this is saying, yeah, traversal query. So then consider creating an index. So if I search with, yeah, so here you can see unsupported operations, operation exception, the query read or traverse more than 1 lakh nodes. To avoid affecting other tasks, processing was stopped. So now, yeah, this 1 lakh is a kind of query limit reads value. So this can be changed, but again the query fails again after reaching the new limit. Obviously, whenever you increase this count, this will impact the overall system performance. So because it's required more in memory to process the query. Yeah, we can change that value in this specific OSA service, query engine setting service. So let me open that. Yeah, so you can change the in-memory read limit here. So like if you feel like the query can be successfully executed by just increasing this value, we can do it, but obviously this will impact the overall performance of the system. The query execution behavior can be reviewed through query performance tool. So let us do that. Go to operations, go to diagnosis. Yeah, here you can go to the query performance. Yeah, even you can see the slow queries here. So obviously this is one of the slow query. Now you can see the popular queries also. Then you can go to the explain query, then just copy that specific query. Yeah, this is the query. I will go back, paste it here, select the language, my case anyway SQL 2. Then I'm selecting include execution time and include node count. Just to click on explain. Yeah, so it's saying like the query reader traversed more than this one to avoid affecting other tasks. Processing was stopped. So even it is not able to explain. So because it's a full traversal query. So now maybe I will remove this include node count. Let me see if it is able to give me. Yeah. So if I'm removing the node count, it is saying like there is no index were used. This is a traversal query. Query execution time, total time, and all those values. So now let's see now how to define a Lucene property index to make this query to perform without any issues. So go to CRXT Lite. Okay, go back to, yeah, let me minimize this, maybe it will take time, so it's a huge data. Let me go into another window. Okay, go under work index. Now I am going to create a new create node. I'm going to name it as test index. Now work query index definition, just click OK. Now here we need to add some properties. First one is the type. I am going to add it is saying Lucene. Okay, now add. Yeah, the next one I am going to add is like included paths. Yeah, so I'm going to just to say, so what does that mean is like I'm going to say to look into this specific path. My path is like content slash sample data. So this is my, yeah, so that's fine, I can type it. Yeah, this is a just select multi, then add slash content sample data. That's fine. Now another property is full text enabled. That should be false because we are going with the property index. Full text enabled boolean. Okay, false, it's not a multi, then add that. So another property is like evaluate path restrictions, where we are using the included path, so we need to add this evaluate. And again boolean, we need to add this as a true. Okay, another variable is like we need to keep compat version. This is of type long, the value should be 2. Add this. Okay, now another property is async. Yep, this is of string. Yeah, this is a multi. I'm going to add async plus NRT. Okay, yeah, so now we can save this. Okay, now it's created. Let me refresh and see. Okay, now if you see like it created another node called index rules, that's fine. Now if you see that it's by default it created with the NT base, because our node type is NT unstructured, the data node. So I'm going to change that to NT unstructured. I'm going to rename that. I'll copy this and just use rename. Yeah, you need to select, you need to keep the node type. If you are going to create this index for, like, let's say page content, you need to keep that CQ colon page content. Here my case the node type is like NT unstructured. I am just keeping the NT unstructured. Now another one is, there is a node called properties. Then if you see here is a property 0. So now I'm going to rename this property 0 to ID, because I'm going to create an index for ID property. I'm just going to say ID. Okay. Yeah. Now this all fine. You can ignore it. Analyzed equal to true. Is regex. So I need to make it as a false. I'm not going to use regex name here. So change this to ID. So because I know the property name is predefined, is not regex. Now I'm going to leave some of this node scope index and the property these values, but the property index make it to true. This is the property index, is not a full index. Then I am adding another property ordered, so the nodes will be in ordered state. It's a boolean. I'm going to make this as a true. Yeah, so yeah, this looking fine. I'm going to save this. Now what we need to do is we need to re-index this. So for that what we can do is, like here if you see, if you go to this, yeah, re-index, right now it's false. Re-index count is 1, so make this as a true. It may take some time, so it will, the schedule job will pick this index, and it will do the it will initiate the indexing. So yeah, let's wait for some time. So here one more thing is, you can add multiple properties. Here is not one property, you can add multiple properties with the required configurations. Also, like another one is, like because we manually did this, so if you want you can use this utility, utility, to generate the index definition. So whatever the query you want to create, for that you need to create a indexing, you can keep it here. So this will give you the configuration. Maybe some property will be little different specific to area, otherwise, like, yeah, this tool is very useful. Yeah, now I hope the indexing would have happened. Once the index is success, it will make this value will be changed to false. Let me refresh. Yes, reindex is false. Reindex count is 2, so is that successfully indexed. Now let me go to this tool again. Let me execute. Yeah, now if you see, all the results are displayed. If I, yeah, if it's still, you see it's a 12,000 result. It took 799 millisecond, but we are not getting any exception like earlier. So what does that mean is, the query used the indexing index whatever we defined. So that's why it's like able to process it. Now again, let us go to the query explain tool. Let me go again. Let me explain again. Now I may include the include node count also. Yeah, now if you see, it's very quick. Also it's saying like the index used, the test index is used. Now query execution time is 1 millisecond, then get nodes time, then number of nodes in result like 12,000. It's showing the explain execution plan also. So if there is a multiple index, it will take the best index. Yeah, now the query is working without any issue and with better performance. So this is best practice to review the slow running custom queries and configure the required indexing to improve the performance. Thanks all for watching the video. See you in the next video.